All right, so here is part 2 of the graphing lesson. So finding intercepts, and we'll be talking about x-intercepts and y-intercepts here. So finding intercepts, I'm hopeful that you all have completed the Desmos activity that I created, and that you are able to sort of gather some nice findings on your own from that activity. And one of the findings that I wanted you to sort of discover was that it doesn't really matter necessarily what's in the denominator. If my numerator is equal to 0, then that will give me an x-intercept. So where my function is equal to 0, that will be where my x-intercept happens. So in order to find these x-intercepts, so to find x-intercepts, we can set the numerator equal to 0. So x plus 3 is equal to 0. So I get here that x is equal to negative 3. So I know that the point negative 3 comma 0 will be on my graph. That's my x-intercept. I know by looking at this denominator here that I'll have a vertical asymptote where x is equal to 2. And to find y-intercepts, I know that I can always plug in 0 for x. So here I can say that 0 plus 3 over 0 minus 2. This is going to give me 3 over negative 2. So I also know that the point 0 comma negative 3 halves is going to be on my graph. I also know that my coefficients are, my degrees are equal, degree of 1 and degree of 1. So I can divide my lead coefficients. So I'll have a horizontal asymptote when y is equal to 1. So lots of information here that we can go ahead and take a look here. I can see that negative 3 comma 0 is a point on my graph. I can see that negative 3 halves is my y-intercept. I can also take a peek here at my horizontal asymptote and my vertical asymptote where x is equal to 2. So one lesson and sort of one problem in, and we already have so much information about these rational functions and what their shape will look like. Let's take a peek at one more here. So my x-intercept, I don't want my highlighter. Here we go. My x-intercept, I'm going to set my numerator equal to 0. So 1 plus x is equal to 0. So x is equal to negative 1. So negative 1 comma 0 is a point on my graph. I know that I'll have a vertical asymptote where x is equal to negative 2, a horizontal asymptote where y is equal to 1, because again, lead degrees here are equal, so we divide our lead coefficients. And lastly, I can find my y-intercept by saying 1 plus 0 over 0 plus 2 is equal to 1/2. So the point 0 comma 1/2 is also going to be a piece on my graph. So lots of great information here just from sort of first glance at this equation. So let's take a peek. Negative 1 comma 0. Here we go. It looks like these are sort of split up by 1/2, so that is negative 1. My vertical asymptote at x is equal to negative 2. My horizontal asymptote again at 1. And here is my 1/2. If this is 1 right here, here is my y-intercept there at 1/2. So here we go. Let's keep going. Set the numerator equal to 0. So here x is equal to 0. So that one's fairly simple. If I scroll down here, x is equal to 0. So that will give me my x-intercept and my y-intercept. The degree of the numerator is smaller than the degree of the denominator, so we don't have a horizontal asymptote here. And I can see that if I factor the denominator, again, that difference of 2 squares, x plus 3, x minus 3 equals 0. I get my negative 3 and my positive 3 vertical asymptote here. So Intercepts are setting the denominator equal to, intercepts are setting the numerator equal to 0 to find the x-intercept and plugging in 0 for x to find the y-intercept.